Good morning, guys. I hope that you are okay. Today we are gonna talk about impulse. As you remember, last lesson we were talking. The impulse is the F net and the times. As you remember, if you apply the force on the object and the object gain the acceleration, and the acceleration meaning that changing velocity. If the velocity is changing, as you know that the momentum is gonna be changed. That's why the changing momentum we called it impulse. As you see that here, F net times time equals changing momentum, and we know that the both side has the same equal units, and this time this part, if we can write here, F equals mass time acceleration normally, and F times time equals delta P. Delta P is the changing momentum. Delta P, as you remember, mass time velocity, and here F equals kilogram times meter per second square times time equals mass time velocity. Here, as you see that, kilogram times meter per second. Look at here, the time here, we rearrange again. Kilogram times meter per second square times, instead of time we can write the second. Actually, unit of the time is the second, equals kilogram times meter per second. As you see, that second cut each other, and the remaining parts are the same, kilogram meter per second, kilogram meter per second, meaning that we can say that Newton times second equals kilogram times meter per second. We can say that this is impulse, this is momentum. The impulse equals changing momentum, as you see that. Okay, look at here, guys. The impulse, a change in momentum in a short time, requires a large force. If you want to have the same impulse sometimes they are gonna show with J, or mostly they are gonna show with the I. The impulse equals force times time. Force times time. If you want to make the same impulse in a short time, you have to apply big force. But if you have enough time, you don't need to apply big force, you can apply the less force. As you see here, change in momentum in a short time requires a large force. A change in momentum in a long time requires a small force, as you see here. If you have enough time, you have just small force. If you don't have too much time, you should apply very big force. Okay? Let's check it here again. The impulse of the force is defined delta T, changing time times force, as you see that. And impulse also is the vector quantity with the same direction as the force. As you remember, guys, the force is the vector quantity, meaning that force has the direction. And as if you check the impulse equals force times time. Time here is scalar quantity. Scalar quantity means doesn't have direction, but the force is the vector quantity, meaning that has the direction. If force has the direction, impulse also should have the same direction with the force, as you see that. Both of them are vector quantity. That's why with the same direction, the impulse is a vector quantity with the same direction as the force. Okay? Yes, guys, let's solve some questions about impulse. As you see here, the question is saying that There is an object of mass 150 kilogram accelerates from a velocity of 5 meter per second to a velocity of 10 meter per second in the same direction. The meaning that at the beginning the object is the 150 kilograms is moving this direction, let's suppose that, with the 5 meter per second, and it's accelerating in the same direction and come here with the velocity becomes 10 meter per second. The question is saying that what is the impulse provided to cause this acceleration? The meaning that, as you remember, we talk about the moment impulse, we were talking about the Newton's second law. If you apply the force on the object gains the acceleration. As you see, the changing velocity is meaning that there is acceleration. The question is saying that what is the impulse? Impulse equals, as you remember, force times time. But there is no any time here, and we don't know the force yet. But we know that this one also equals changing momentum. Okay, and this changing momentum will give us the impulse. How it is, what we can find the changing momentum? We can find the first momentum P1, and after that we can find the last momentum P2, and after that delta P equals last momentum minus first momentum, and it is vectoral quantity. And if the same direction, minus meaning that change this one, make the opposite, as we can draw here again, delta P equals this one, the P2. What is the P2? P2 equals 150 times 10 equals 1500 kilogram meter per second, minus P1 meaning that change the direction of P1 and make it add. This is the minus P1. Minus P1 equals 150 times 5 equals minus 7500 meter kilogram meter per second. As you see that, let's take this one a little bit down and continue here, and delta P equals 1500 kilogram meter per second minus 750. Sorry, this is not the, yeah, this is the 150 times 5 equals this one. Okay, kilogram meter per second, and delta P here equals 750 kilogram meter per second, or 750 Newton times time, as you see that. And the answer will be A.